Tuesday. But anyways, we're going to make some bullets happen, and the main idea here, I'm going to get rid of this. There we go. Out of the way. The main idea here is that we're going to make not just a new class for bullets, but we're going to make a whole engine, which is really just a loop that's going to automate the processing of various objects in our game. But we'll just start off by making a loop that's going to process all of our bullets. That's going to be our main goal today. We'll make a bullet class too, and it should represent bullets and all that good stuff. We'll just make it a rect or an ellipse or something for now, and we can spruce it up later on. And then the machinery of this loop is going to be the main thing to get from this lesson. Kind of a reminder of last year. And I'm going to keep it simple. Somebody mentioned a couple classes ago abstract classes and stuff like that. We'll get into that, but I think first we'll just make a loop that will automate a list, not an array this time, but a list of bullet objects. And then we'll expand it to allow in other things like asteroids and the spaceship itself and other stuff. So I'm not sure what we should do first. We should make the bullet first or the machinery to automate the bullet. But maybe we'll just throw down a bit of basics for the bullet class. We won't fill it all in. We'll just get something made so that we sort of know where we're going with it. And we'll put the details in later. But once we have a basic sort of format of how that's going to look, we'll go make the loop that's going to automate all the bullets. So once we fire, we can just step away, and the loop will take care of making the bullets move along and do their thing. So I'm going to make a new tab. It's going to be the bullet tab. And we're going to make class bullet. And since this is partially a review about object-oriented programming, let us recall the 3 things every class needs in order to make it a functioning class in processing. There's 3 things. Someone yell out. I know, Tuesday morning after a long weekend. This is going to be hard. And also my hearing is impaired right now. I don't know why, but my ears have been plugged since I went down a water slide in the summer. I really should go get that checked out, I think. It's getting worse. I better get that looked at. But nonetheless, just yell as loud as you can. What is one of the 3 things that we need for a class? Instance variables. All right. That's the first one, too, so that saves me from having to press enter. You got it. Instance variables are, of course, the data that every single bullet will remember, and they'll each get their own copies of these variables, so you don't have to make, location 1 and, whatever, damage 1 and all that kind of stuff. So our variables are pretty straightforward. I think we just need a location. It says we're doing p vectors. Let's keep it all in p vectors, hey? So we'll make a p vector for its location, which is like float x, float y last year. That's kind of what we did. Bless you. And also p vector for velocity, because they're going to be moving. We could break it down into direction and velocity like we did our spaceship, but we're not really going to be turning the bullet. I mean, maybe you'll design a cool heat-seeking bullet or something that will require you to do that, but for our basic bullet that's going to travel in a straight line that'll come out of the spaceship's gun somewhere, or nose or whatever, then we really only need these 2 things. Direction allows us to sort of select what the velocity will be of the spaceship, and we'll make it also the bullet as well. Anything else? Maybe like an image, but we could store that in the main tab. We don't have to store a separate image for every bullet. We can just use the same image over and over again. I guess we need the second thing now. Instance variables. Yeah, someone said it. Constructor. Constructor is that special function that makes the bullet come alive. But also, really, the main thing is that we're going to program is the initial values for those things. So we'll call it bullet, which is always how you call your constructor. There's no void in front of it. Avoid the void for your constructors is our slogan. It's bad humor, but it's memorable humor is my hope. I don't know if it's true. And then, of course, the name of the constructor is the exact same name as the, I wish I could scroll up, there we go, as the class. So note the capitalization there is consistent. And then we just give it sort of the default values, and you might be wondering, well, what values should we give it? So the bullet could access the spaceship or we could just have we could send the information to the bullet through these parentheses. I don't know. I'm not sure which one we should do. I guess my goal is to keep it fairly simple. So I think what we'll do is we'll leave these blank still for now, and we'll have it pull that information from the spaceship since that's available. But I'll leave that blank for now. We'll come back to it. And what's the third thing that every class needs to have? Yeah, the void show and the void act, which the general term for those functions is behavior functions. You got it. And we basically have been doing void show, void act for everything, so we're going to do that again. And we're sort of standardizing that on purpose, because later on we're going to make it so that all of these things, whether it's a spaceship or a bullet or an asteroid, can all be gathered into the same place, in the same data structure, the same list. And if they're all standardized, then they can all be told to show and all be told to act. And that'll be relatively simple. We're not quite done that story yet. Bullets also need to die. And you can decide if you want to make a separate function for that or not. I haven't decided whether we'll make it separate or not. It'll either be a Boolean variable here in our instance variables. They'll be like keeping track of whether it's alive, or it'll be a function. And let's make it a function, just so we have something other than void for a change. So yeah, we'll make another function. Boolean alive, which will return true if it's alive and false if it's not alive. And notice it's like grr arg, it's mad. It must return a result of type Boolean. So right now let's just return true. They're always alive for our default sort of situation here. We just have to do that to run, because once you don't put void in here, once you have a type here, like Boolean or int, then if you don't return it, then it's like, no, I refuse to do anything. I'm waiting until you, human, return the value, because you promised me a Boolean, and I need a Boolean. So we'll just put that in there to satisfy processing for now. So this is our kind of skeleton of our class, and it's pretty similar to other things. So that's good. They're all very similar, as it turns out. So now what we want to do is, before we make the guts of it, it would be nice to be able to test it, right? To be like to see, hey, does this bullet move? So we're going to make the machinery that'll automate the bullet and all the bullets moving. We're not just going to have a single bullet that we shoot and reuse over and over again. We're going to make a list that's going to store the bullets. And when we're not shooting, the list will be empty. It'll have no things in the list. And then when we shoot, we'll add things to the list. And once there's things in the list, that loop is going to be going to each index in the list, each element in the list, and saying, hey, show, act. And it'll move down the row and be like, hey, you show, act. And you too, bullet number 2, you show and act. It'll just kind of go down the line, go through the list, and make all of them kind of show and act. And ultimately, we'll also get them to remove when they die, when is alive gets to false. That's false. Pull that bullet out, throw it away, and that'll be good. So let's go and do that. So I'm in my main tab now. Everybody else there with me? And I think I'll be doing a little bit of illustration of the list as we go. So maybe I'll move this up. I have some space to draw on the board. Oh, there's our P back there still. Our moving stuff. I'll just erase those. All right, so we're going to make a list, which is very much like an array. The structure it makes is like an array. The only thing that's different with a list, there's some syntax that makes it look different, but really the same structure underneath, except it can grow and shrink. That's the big deal about a list. And in particular, in processing, the one we're using is called an array list. There's actually many kinds of lists, but we're going to use an array list. And this is how you make an array list. You say array list, and then you have to say what's going to be stored inside. And I'm going to store bullets for now. So I say array list bullet. And this is like saying int or Boolean or pimage. It is the type of thing. So then we have to give it a name for our list of bullets. I'm just going to call it bullets. So the word bullets refers to our list of bullet objects. This is what it contains. This is its name. Yeah? Good so far? Okay. So once we've made this bullets thing, it's actually not built yet. We have to tell processing to instantiate it, is the term, which is just a fancy word for make it. So we have to go and actually build the list. It's just an empty variable right now, a null pointer technically. So in my setup, I'm going to go to the bottom of my setup and just press enter a little bit and put in list stuff over here, the list. So just at the bottom of my setup. So I'm going to say bullets equals new array list bullet, and then 2 parentheses, which is a pretty ugly syntax. This is about as ugly as, it's not as ugly as it gets in Java. There's never a limit to how ugly it can get in Java, but this is pretty ugly with the angle brackets and the parentheses happening in here. Ugh, it's kind of ugly. So what's happened after we've done this line of code is we have bullets. It is a fully functional list, and there's just no items in the list. Technically, it has made an array in here, and there's all sorts of spaces, and it's going to manage those spaces and grow it and shrink it and stuff. But right now, as far as we're concerned as the programmer, we can pretend it's just some sort of empty list that has no items attached to it whatsoever. So I'm not sure how to illustrate that as a structure. I'll just put like a blank space here. You know, a blank canvas in which to add items in our list. And you might wonder, well, how do things get in that list? So what we can do is we can go make the shooting code in our spaceship that will make a bullet and then add it to the list. So we can, because we can't really test this code until there's things in the list. So let's go do that. We're going to jump around a little bit here. So I'm going to jump over to spaceship class, and we'll see how do we add bullets to the list. So here I am over in spaceship, and I'm going to add in, I guess in act right here. This is in my act function. You probably have something similar where you have the reacting to keyboard inputs part of your code. So I'm going to use the space bar to shoot. I can't wait till there's a colony on the moon so they can call like the pub and the moon the space bar. I think that will be excellent improvement to the lunar landscape. And for shooting, I mean, it's the one, if you're going to hit something in panic, you want to hit the space bar. It's large, easy to hit. I think mine's already set up, actually. Let me just double check. I'm going back to Asteroids. And, oh, yeah, I already have a space Boolean variable. And I have, here's me managing the space bar. This one's a little bit tricky. A lot of people ask me, well, what's the key for the space bar? Like, what character do you put in? And it's just the space. Which is like, people are like, oh, yeah, of course. But, like, you know, over the course of the last few years I've been teaching this, like, I don't know, I've been asked that question like 50 times for sure. So don't feel bad if you don't know. Notice that because there is a character, although it is invisible, there is a character that you can type with the spacebar, so you don't use key code, you use key. And these are single quotes, which is important. Don't worry about it, but that denotes a character as opposed to a string, which is only a single symbol. And if it was double quotes, it would be a string, which is something different, which we'll be learning about later in the year. But that's how I do it with making sure I'm pressing the key, space. So that works, so I can say, hey, if space, and we're going to add a bullet to the array. So I can say bullets dot add. So bullets is our list, and bullets can add things. And what's it going to add? Well, it's going to add a new bullet. And so we can actually call the constructor right here in these parentheses for our bullet class and do it all in one line. We don't have to make a variable for this bullet because we're not going to remember it. It's not, none of the bullets are particularly special. We just need to make sure it gets in the list and let the list take over from there. So we'll say add a new bullet. So every time we press space, you can imagine that a new item will be added to the list. The first time we press space, we'll get a bullet inside of this list. I don't know, maybe I'll just draw it as an actual bullet. Your image of what a bullet is may vary. This is a space bullet, so it probably shouldn't be like, well, I guess that's fine. It could be like a bullet like this. And then it is numbered what as the first bullet? What's its index? 0, yeah. Add always adds to the end of the list. So if you press space again, it'll add another one after it. And that'll be element 1, and so on. And then we can remove them, or they can remove themselves as they get old. I'm not sure what the way we'll do it is. It could be distance traveled. It could keep track of how far it's gone so it can remove itself. It could be a timer, how many frames it's been around. Either way, like that'll amount to the same sort of reaction. So every time we press space, we'll add in a new bullet in the list, and they'll eventually be removed as well. We'll have to put that in. Just keep on going down the list. Of course, each bullet will have its own p vector, location and velocity and so on, and it'll be keeping track of all that information inside of there. And we need some kind of machinery now that will kind of, every frame, go through all the bullets that are in the list. So it'll visit bullet 0 and be like, okay, show yourself on the screen, draw your picture of a bullet, and then move. And then bullet 1, you do the same thing, show and move, or show and act. And then number 2, you do the same thing. And that was like one frame. All the bullets are animated and told to do what they were designed to do. And the next frame comes along, and the same thing's got to happen. Like you, show yourself, do your bullet thing. You, do the same thing. You, do the same thing. It's got to kind of go through. And every frame that's got to happen. So I'm going to put that into my draw function, because that's the thing that happens every frame. That's the code that is executed constantly over and over again. And you sort of already have this idea. I'm going to go back to my main tab here and back up to the draw function. We're already doing this with ship.show and ship.act, and that's great because our ship's always there. But the bullets aren't always there. Sometimes they're not there. Sometimes there's many of them. So we need something a little bit more adaptable, I guess, to handle multiple bullets or no bullets. Kate, thanks for your question. Oh, that's such a good question. Thank you. Yeah, if a bullet 0 is probably going to be the one that will die first, right? If they have time limits on them, then this one will die. So what happens to these ones? So they will all shift down. And I'm too lazy to redraw them all, so I'll probably just like do this. And then this becomes 0, and this becomes 1. That's a 1, I swear. And that is all sorts of annoying for programming in the future of what we do. If we remove something, we're going to have some problems, because if you're on the first one and you remove it, and then you move to the next one, well, you move to number 1, but number 1 was number 2, so you end up skipping bullets. So there's an easy way to deal with that, and we'll deal with it in a second, but let's just make this the basic thing happen. But thanks, Kate, for mentioning that, because that's a thing we'll have to take into account. Our bullets don't actually die just yet. Well, I guess they can die. Okay, so we're going to make a loop. We're going to make a loop for taking care of our bullets. So I'm going to put in the bullet. This is what we referred to as an engine last year. It is a piece of code that automates a process of some kind. And so I'm going to move this down a bit. So if I call it the bullet engine, I wouldn't be, I wouldn't be overstating it. So I'll just use that terminology to stay consistent with last year. The thing that drives the bullets, makes all the bullets do their thing. And the way we do that is with a while loop. Because if you notice, I'll put in my last bullet's a red one apparently. Not too sure why. Maybe they have random colors. 0, 1, 2. Hey, that's a pattern that we can make a computer count, right? We can make a count 0, 1, 2, 0, 1, 2, 0, 1, 2. And that's something to do with while loops that we were studying at the beginning of the year. And last year as well. So what we need to do is make a loop that counts from 0 all the way up to however many bullets there are, minus 1. Notice there's 3 bullets there, but we count up to 2. There's 100 bullets, we count up to 99. So we start counting from 0. So let's make that while loop. Can we make a while loop that counts? Let's just say the number of bullets is n right now. Let's just call it n. Good old math teacher trick, right? Don't know what it is, just give it a variable. So if we called the number of bullets n, what would be a while loop that would count from 0 to n minus 1? Think about that. Go ahead, even type it down right now if you want to try it out. I'll wait. Everyone on YouTube will wait too. All tens of people watching this video will be like sitting there. And that's an overestimate. My #1 watched YouTube video has 400 some views. It is me swinging my katana to cut open a watermelon. Yeah, it's a good one. I'll tell you that story if I haven't told it to you before. I feel like I tell that story every year, but I guess sometimes I forget to tell a class. Someone in here has heard that story, I'm sure. We'll watch it later. Hey, we'll watch a YouTube video and record it and upload it to YouTube, so it'll be a YouTube video of watching a YouTube video. That'll be fun. Anyways, I'm distracting you.
Like spacebar.
Yeah, spacebar, self-referential. Yeah. So glad you guys are my first block back from the long weekend. Because I'm loopy and you guys, well, you might mind, I don't know, but you seem to be liking things. All right, well, if you didn't get a chance to finish it, it might just be because it's Tuesday after a long weekend and you're having some trouble. So let's take a look and see how that would work. I'm making a loop that's going to count from 1 to n-1. You can make a for loop or a while loop. I'm not sure which one you're going to do, but I'm going to make a while loop. So I'm going to make a variable that will count. And I put it inside of here because I don't want to reuse that variable. And I don't want it to get confused with other loops that might be out there in our code. So I'm going to use I. I stands for index. It's not special. Like I could use any letter here or any name, honestly. But I'm going to use I because that's pretty traditional. And I don't want to mess with tradition right after Thanksgiving. So here we go. We got our while loop. I'm going to do while. If you did for loop, that's fine. And the condition is while I is less than n, where n is the number of bullets. I use less than, so it doesn't quite get to n. Right? It'll not quite get to n because when I is equal to n, that will not be less than n. So if there's 100 bullets and I was 100, 100 is not less than 100, so it won't run. It'll only get up to 99. So that fact that I chose that symbol is what makes the n-1 thing happen. Yeah? Yeah? All right. And then how do we count up? Well, it's just I++ is what we did last year a lot, or I equals I plus 1. That just increases the count. So when this loop starts, I is going to be 0. 0 might be less than n, depending if there's no bullets, it won't be, in which case this loop won't run, but that's okay, because if there's no bullets, we don't want it to run. So that's a feature, that's good. But if, say, n was 3, then 0 is less than 3, so it'll go and, well, do nothing, and then add 1 to I, so it'll become 1, and then it'll come back, and 1's still less than 3, so it'll do nothing, and then it'll increase it to 2. 2 is less than 3, awesome, and then it'll do nothing again, and then increase it to 3. Hey, 3 is not less than 3, so it'll stop. It'll leave the loop. But notice that in the course of that loop, whenever it got to this kind of blank line here, I can't do much with this line. This line here, I had gotten a chance to be all the numbers from 0 to n-1. So now we can put in code here to access the different bullets that are numbered 0, 1, and 2, or whatever their numbers happen to be. Sound good? Was that clear? Yeah? Okay. See some people that are like focused on their computer screens, and I'm like, I'm hoping they're auditory learners, and that's okay. But I'll let you decide where your brains need to be focused on right now. So the last thing is really just to make the bullets show and act, and we'll probably want to remove them as well. Yeah, let's do all 3 of those things. We're going to show them, we're going to make them act, and we're going to remove them. So the first step is we have to get the bullet out of the array list. This is where I like arrays better, because you could just say, whatever the name is, and then square bracket I, and that would refer to, bullet 0, bullet 1. You can't do that with array lists. There's no nice little syntax like that, which makes me sad. I'm like, oh man, this is where arrays get kind of annoying. So what we're gonna do is we're gonna get an element out and store it in a temporary variable. So I'm going to call this variable current bullet. This is the one we're currently looking at. So we're going to make a variable, and this is just a bullet that's going to represent whichever bullet we're currently on. It's going to get a chance to be bullet 0 and bullet 1 and bullet 2 all the way through. So check it out. I'm going to make a bullet variable called current bullet. And we're going to grab a bullet out of the list and stick it into this variable. So the way I do that is I say bullets, that's the name of our list, dot get I. And actually, let's make this visual happen. I have a green bullet, a black bullet, and a red bullet. Sorry, YouTube users, you can't see this diagram. Sucks to be you. Come to class. No, just kidding. Some poor kid's sick. He's like, Mr. Pelcher hates me. I'm sorry. It's not my intention. All right. So in addition to this diagram now, we got the bullets list. We also have a current bullet over here. Current bullet is right now, when it starts off, it's going to be empty. It's going to be a null pointer. But when we say equals bullets.getI, what it does is it takes a bullet. It doesn't actually remove it from the list, but it sort of links itself up to this bullet here. It's probably a good way of saying it. It might be easier to visualize it as like getting a copy of it or something, but they're technically linked. So it doesn't really grab it and pull it out. It links itself up to this bullet here. Think of it as like a plug, plugging in. So this bullet here might be a good way of saying it. So once it's plugged into that bullet, if we tell current bullet to show an act, we're actually telling that bullet to show an act. Because it's this line of code links it up to whichever index we tell it to do. So then I can say current bullet dot show current bullet dot act. And it's going to be the green one that's showing and acting on my diagram. And then we got to also remove the bullet from outer space if it expires. So we can say if current bullet dot alive. Oh wait, that doesn't work, does it? We don't want to remove it when it's. Oh, sorry, I missed some parentheses there. We don't want to remove it when it's alive, so we want to make that. We could do it, I guess, two ways. You could say if current bullet dot alive equals false. That's probably the easiest way. We'll make an if statement to check if it's dead. Here's another way which you don't have to use, just funsies. This is sort of another way is you can put an exclamation mark on the front, which stands for not. So you can say if not current bullet alive, which is kind of the standard way of doing it, but I don't know why. And I mean, I guess I kind of know why. But if you're happy with false, then you can choose whichever one you want to do it. So current bullet.alive equals false. If it's not alive, is what we're saying, then we're going to remove it from the list. And guess what? Lists can do that too. We can say bullets.remove. And which number is it? Well, it's I. Remove I. So we'll actually get rid of it. And we don't have to do anything else. Once we remove it, it's gone forever. And there's this great thing in Java called the garbage collector, which sounds like a funny name, but it's part of what makes Java great and bad at the same time. We don't have to do anything. If this was C++, we'd have to do so much, well, a bunch of work to make sure that memory gets recycled back into the available pool of memory for computers. But Java does all that for you. There's this watchdog that's watching for you, removing things or doing various things, and it will then recycle that memory for you. It makes the job of the programmer easier. Some people hate that, though, because it is a constant overhead that's always running in Java programs. And if you're not, if you could manage it more efficiently, well, too bad. You gotta use it. So some people don't like it for that reason. But there is still a problem, though, and that was what Kate mentioned. Kate was saying, hey, if you remove something, what happens to the numbers? And they slide back, right? So if I actually removed bullet 0, then 1 would become 0 and 2 would become 1. And then if I go I++, I'd actually go to 1, which was the old 2. So I'd skip over the old 1, which is now 0. So the trick is you just do I minus minus. And then you kind of slide the counter back with all the bullets that are sliding back as well. There's another trick as well. There is the trick where you can just go backwards through the list. And then you don't have to do any minus minus. Or I guess you'd always be doing minus minus. You can start at the end and go backwards because it always shifts to the left, and so you can do either one. Unless you're an AP Computer Science, though, you don't really need to do either one. You can just do one or the other, and it's totally fine. So there you go. There's our engine. The only thing we're missing is n. N doesn't really know anything. It's just some number. So we have to say, what is the code that figures out how many things are in the list? And the answer is bullets knows. You can say bullets.size. Bullets.size is the number of things in the list. So probably not today, but someday we were going to generalize this for all of our game objects. So we'll have, not just bullets, but asteroids and spaceships and particles and fire and all that kind of stuff in there. A ship will be in there too. So later on we'll make that happen. But right now, this is a great structure. Is there any questions about this structure? Thanks, Zach.
So when you're calling like the very first line of code there, like current bullet equals bullets.get.
Yeah.
Isn't that like, I'm kind of confused what actually.
Oh, I'm so glad.
Are you just calling that over and over and over again? Like, aren't there just going to be like hundreds of current bullet?
Yeah, great question. I was going to do a little like not puppet show, but like reenactment of this code as it runs.
Yeah.
And ask that question again if it still doesn't make sense after I do that. Because I think that will show you what's happening. But it might not still be clear, so let me know. But we're going to try that. Well, let's get Harry's question first, and then we'll do that.
Sorry, the I minus minus. So like you said, when the bullet dies, so it's not alive anymore. You said everything in the list like shifts, right?
Yeah.
But then what is that I minus minus achievement?
So it shifts the counter as well. So for example, I'm so glad you asked. So say this bullet turned out to be expired, it would be removed. Technically this thing is still plugged into it, but don't worry about it. And this would become our new bullet 0 and our new bullet 1. But I is still 0. So when we increment it to go to 1, it'll now go to this one. Because at the end of the code is I++. So when we go to get the next bullet, I is 1, and we skipped over this one. So we actually have to decrease I, because these things shift back, so we have to shift I back as well to keep it in line with all of our lists. Yeah, makes sense? Yeah. Awesome. Because that's not an easy thing to know. My AP students also struggle with the same thing, so, that's great. Apparently it's supposed to be blue now, because I can't find my green. Oh, no, it's not going to be that either. Oh, but hey, there's my green marker, so it all works out in the end. Woohoo! There we go. So 0, 1, 2. I'll put those numbers back. Okay, so I'm going to reenact this code. I think this is probably the most important part of the lesson. So YouTube users can't see anything, so it sucks to be you. But anyways, we're going to start off. I don't know why. I'm not sure if there's a point to recording this or not. Use your imagination as I speak with words. So we got ourselves our array list. Let's say there's 3 bullets in it, numbered 0, 1, and 2. Yeah? Good. And then there's this kind of illusory current bullet thing. So watch what happens to that as we go forward. I would like a meter stick. Yes, the gesture. So our first line is I is set to 0. Let's put I out there as well. Here's I. It's going to start off as 0. And so when we go into our loop, 0 is definitely less than bullet size, which currently is 3. So 0 is less than 3, so we'll go ahead and do things. So our first line of code here, I'll highlight it. Nope. So hard. Not really. I'm just having trouble. There we go. This line of code. Yes, this line of code here. When it runs, what it's doing is taking current bullet and connecting it to one of our bullets in here. Which one? Well, it depends what I is. So bullets.getI means it's going to connect itself to bullet number 0, which is the green bullet on the diagram, the first bullet in the list. So it's going to plug itself into here. So whenever I refer to current bullet, I'm actually referring to the bullet, the green bullet, the bullet in this thing here. So then I'll say current bullet.show, so it'll draw the green bullet on the screen. And then I will say current bullet.act, so whatever that does, we haven't programmed it yet, but it'll probably make the bullet move along its vector. And then we'll check to see if it's alive. If it's still alive, then it won't do this. If it's not, it'll remove it from the list and organize I so that it doesn't get off sync with the rest of the list. And then at the end, let's say it doesn't get removed, it would do I++. So now I becomes 1. And we do this all over again. So we go up to the while loop. And note that the condition only gets checked once during the whole loop, right? It's not constantly checking the whole way through. That's something that people sometimes forget. But it'll check this condition this one time. Is 1 less than 3? Yeah, you bet. So it goes in and does this. So here's Zach. This is where your question comes in, I think. So we're going to make current bullet again. And this time, so when I remake it, it just recreates a new copy of the variable. We could have declared it outside. We just reuse the same copy of the variable. Doesn't really matter which one you do. But either way, it's the old one's destroyed and this new one is recreated. So it's really just as if there's just one there. And then we say get 1 this time. So when we say bullets.get1, we're referring to the black bullet. And so it plugs into the black one this time. There we go. And so when we say current bullet.show, now it's referring to the black bullet. So it shows the black bullet on the screen. Outer space, rad call for a black bullet. Stealth bullet, yeah. And then we tell it to act. So current bullet is pointing to black bullet, so then the black bullet acts and presumably moves along the line. See how that works? And what we're doing was we're just kind of, this whole loop is just counting 0, 1, 2. And what we're doing with that 0, 1, and 2 is plugging in this variable into each bullet as we're counting 0, 1, 2 and telling it to move and show and all that kind of stuff and possibly remove it. So it's just that whole loop is kind of moving that down the row. And unfortunately, it's really just a matter of the syntax being ugly that we have to do it this way. Arrays are a lot easier. We could refer directly to the things that were inside of an array, the square brackets. Lists just require an extra step to make this variable. I mean, I guess there's a way we could do it, but it's even uglier to directly access it. Okay, what do you guys think about that? Is that making sense? And that's just actually what the engine was last year, in case anyone was like, oh, that engine stuff was crazy last year. I wasn't sure what was going on. It's just, we have more than just bullets in there. We had all of our game objects, and we'd have, this was called OBJ. Remember that? Obj. We made jokes about obj. And it would just move its way through the list. It would become spaceships or bullets or nebulas or explosion particles. It would just become a different thing. And each time we would get those things to show and act as we go through the course of that thing. It'd be nice to actually see some bullets today, though, wouldn't it? We've done a lot of work. But bullets still don't shoot. So we better go fill out our bullet class. So I'm going to go to bullet class here. While people are reorienting themselves, just a shout out to the comic 100 Bullets. Super good if you get a chance to watch it. It's or watch it. I guess you're technically watching it. More and more likely reading it. The plot line is it just takes place in normal everyday life. Like there's not superheroes and stuff. And the idea is that this random gun just appears to people. And it has 100 untraceable bullets that you have access to. And if you use the gun, there are no consequences. So if you go and shoot somebody, like you will, like there's like some sort of powers that be that are operating in the world so that you will get off scot-free. There will be, like if you go, like if the police arrest you or whatever, like within 24 hours you'll be free and there'll be no more questions asked about the act. And so every issue, a different person gets the gun. And and as the story unfolds, you learn more about sort of the mechanisms and power. It's really cool. It's a good tale. So check out 100 bullets. But right now we'll work on our bullet class, and we should probably get it to show up. So our location, when we make our bullet, where's it going to be probably? Yeah, it's going to be at the ship. We're going to show up at the ship. You might need to align them differently if you have like a gun on the left, like if it's a B-wing or something, and the guns aren't like lined up with the center, then you might need to do that. But for me, I'm not going to worry about that. So I'm just going to say, hey, I'm going to borrow the location of the spaceship. Low action, man. Location, there we go. Location equals, how do I get the ship's location? Ship, yeah, dot location. Low action. I can't type. So it's like saying, hey, I'm going to borrow your location. You know, actually, I'm having second thoughts, but I think that'll work. I'll have to double check. Now I'm thinking that might actually not work. Well, we'll try it out and see. That's always a good thing to do. We'll try it out and see. We might get some weirdness happening. I think we might get some weirdness happening. Yeah, I don't know. We'll come back to it. It also needs a velocity. So what's its velocity going to be? Well, if this works, it's great, but I'm kind of doubting it's going to work now. We don't want it to move in the direction the ship is moving, because it could be like drifting along and you've rotated and you're shooting sort of parallel, or not parallel, sorry, perpendicular to the direction you're gliding. So it's really about the ship's direction. You want to line up the shot with the ship's direction. We say ship.direction. And I think there's going to be all sorts of horrible things that are going to happen there. But that's okay. Learning experience. I think the problem will be is that the locations will be linked. So if you change one location, it'll change the other location. So I'm pretty sure that's going to happen. But that's okay. We'll solve that as we go. So yeah, I think when you shoot, it'll actually make the ship like, it's like when Thor throws his hammer and then flies along with it. Like that's sort of what's going to happen here, I think. But that's okay. That'll be funny. And then we're going to then make the ship show. So that's going to be, for me, I'll just do ellipse. Ellipse at location.x, location.y. And it's going to be, I don't know, not that big. I'll make it 20 by 20 just so I can see what's going on. Maybe I could fill it with something, but I won't worry about that. Maybe I will, just in case. I don't want to make things go invisible. I'll make it a white bullet. Because black bullets you can't really see on outer space background. And then its act function is pretty straightforward. It's just going to be location dot add velocity. So I think this is going to be something terrible that happens. Also, you know, I realize now that with you guys kind of typing this down in 3 different tabs and not running it yet, the potential chances for errors occurring is enormous. Like, you know, just missed one semicolon after trying to type all this stuff down, then you're in trouble. But hey, we're in advanced programming for a reason, right? I'm hoping everyone's going to be, you know, at least, you know, maybe just a couple errors. Hopefully nothing too major. But now that I think of it being Tuesday morning after a long weekend, maybe that was a bad idea. That's pretty much all I'm going to have it act. I'm going to leave it to be an immortal bullet for now, because I'm just testing. I don't need to worry about the bullets going away. Yeah, let's see what happens. Is it like Mjolnir where you throw the bullet?
Yeah, it's stuck to it. Yeah.
Oh, yeah.
It gets faster.
Yeah,
Bullet adds speed to your spaceship.
Yeah.
So what we've created is a ramming weapon, so I can ram my bullet into things. Yeah, that's a problem, and I guess I'll mention why that's a problem. So when you do this, you're actually linking your location and the ship's location. They're tied together. So if you change one, you change the other. What I'd like to do is get a copy of it. I actually prefer to get a copy, not link them together. And actually, is there a p-vector? Let's just check if there's a p-vector method for that. If not, we'll have to do something a little bit uglier. Let's go with p-vector processing. Let's see if there's a thing that returns a copy of a yeah. Copy. Hey, gets a copy of the p-vector. Woo! All right, I'm excited. So instead of linking it to the actual spaceship's location, and then they're like permanently linked, so as one changes, the other changes, what we'll do is link it to a copy of the vector, so that they're not linked. The spaceship's location is not linked. So I'll just put in .copy at the end of that. So it'll be .copy. A lot of dots in that line there. So it's linked to a copy. We're gonna not, you know, it'd be like handing in the same assignment with 2 names on it. Be like, I did my homework, Mr. Pelletier, as opposed to taking a copy of the person's assignment and putting your name on that, and then handing in 2 separate assignments. Does that analogy make sense? No? Yeah, does it work?
If you drop mine.
So move your, if you move your spaceship while holding it.
Looks okay.
You hold down space.
If you hold it, you can.
Yeah, we're actually putting down many bullets. I don't know if you can see, but Space will put down several bullets. So we're putting a ton of bullets in. Now, there's a couple of things that suck about this. Why are our bullets so slow? Shouldn't they go fast? So it's actually the direction. Yeah, the direction is actually a really small vector. So we'd like to actually make that bigger. And we can choose its size. So we can set what's called the magnitude. So velocity is going in the right direction, but it's not fast enough. So what we can do is we can set the magnitude. It's called, the magnitude is how long the vector is, or like how fast it's going to move, without changing the direction. So direction is the right direction. It's just not fast enough in that direction. So we can add some stuff to it. So what I'm going to do is I'm going to add in, let's see. Let's go to, oh, I had it. So magnitude calculates the magnitude, but we can also do, I believe it's set magnitude. So we can set the magnitude of the vector, which is to say, without changing its direction, like go faster in that direction. So we're going to use set magnitude for that. So after I do velocity equals direction, I'm going to say velocity dot set mag, and you can choose a number, like say 5. And that means it'll move 5 pixels every frame, but it will get the direction. So let's see what happens now. Whew. They fly off. I gotta zoom out here. Pew. Yeah, we got a bit of a problem with rapid fire, hey? Some people say problem. I say feature. Yeah, bug or feature. Lovely spirals we can create. And you can feel free to play with different magnitudes. If you don't like that speed, you could change it up to be faster or slower. It's all just about setting the magnitude. So our velocity vector gets its direction from the spaceship, but then sets its own magnitude. So whatever direction it's facing, it's going to move 5 pixels per frame. Just depends on the angle. Okay, so what are things do we still have to do? So we have to get it to not rapid fire. What else? Anything else we have to do? Make it pretty, I guess.
Does it die outside the screen yet?
No, it doesn't.
Yeah, I gotta do that.
Yeah, we gotta do that. Because eventually our list is gonna get enormous. Like if we keep shooting, those bullets aren't dying. And the list is growing, like it's in the hundreds at this point, maybe thousands. And every frame, it's kind of cool that it hasn't lagged or dropped any frames yet, right? Like there's thousands of bullets to keep track of, and that list is telling each one to show and act. Even when it's off the screen, it's still saying draw that like it's in I don't know, like at the airport by now, you know, like it's in southern Vancouver at this point. But yet it's not really dropping any frames. So that's kind of cool. It's getting a little bit slow now. I see it dropping some frames slightly. So yeah, we gotta do those two things. Let's just finish off class with getting those two things to work. Oh, thanks, Ben. Question? They like bounce off in some direction. I guess I'll just show you. I'll just show you what I got at the moment. I have, this is all I really have for the velocity. If you have similar things, then I'll come and take a look at it. But just in case that helps, I'm take a look at that. So I'm getting, notice that it's velocity equals ship.direction.copy, not ship.velocity.copy. That might be a thing that's happening. But I'll come and take a look after we've solved these last two problems. Okay, so let's do it. So we got to make it so we only shoot every once in a while. We can make ourselves a cooldown variable like we did last year. Remember the cooldown variable? So a cooldown variable lets us shoot when, you know, a certain variable has a value greater than whatever number you want it to be. Say 100. And then whenever we shoot, we set that number to 0. So we can't shoot again. But every frame, we count up by 1. So eventually it'll fill back up again to 100. and beyond, possibly. So we'll make a cooldown variable for that. So that's going to be one of my instance variables. No, actually, I don't want this in the bullet, do I? I want this in the ship. The ship is going to cool down. The bullet's not going to cool down. So in my spaceship, in addition to lives, I'm also going to have a cooldown variable. I'm going to make an int. So I'm just going to stack them all there. And I'm going to start it off at, I'm just arbitrarily choosing 100. But we can see what happens if we change it to different things. So in the constructor, I'm going to set cooldown to 100. And then, not so much in the show function, but in the act function. So I'll move on down here. I'm going to say if the space button is pressed, and then I'm going to also put an additional constraint to say that cooldown's got to be 100 or bigger. So I'm going to say and, the double ampersand is and. Cooldown is greater or equal to 100. Which has done nothing yet. But check it out. I'm gonna add in another thing. I actually want two things to happen now instead of just one thing. So I'm gonna have to add in some braces. So get ready for adding braces, and you know how dangerous that is. There should be like klaxons that start ringing and like red lights come out, like incoming braces, incoming braces. So watch out. So I'm gonna be adding in these braces. So this if statement, it's not just gonna be one line anymore. It's gonna be two. So I'm gonna add a brace here. I'm gonna add a brace there. Everybody see that? No one lost the braces? I've added in the braces here so I can make two things happen if that condition is true. I'm also gonna make a cooldown now equal to 0. And if I left this code as is, I can shoot exactly one bullet. So we have to let that cooldown variable charge up again, back up to 100. So what I can do is, outside of those braces, wherever you want, doesn't really matter. I'll put in a comment to say recharge the gun. I'm going to say cooldown plus plus. Every frame it's increasing. If I shoot, I set it to 0, but eventually, after 100 frames, I guess, it'll increase back up to the threshold, 100, and it will allow you to shoot again. So just to illustrate what's going on here, because I feel like if you just are writing this down and not understanding it, that might be your approach. But you'll get a working game and have no knowledge. And the point is, this is a review exercise, right? I mean, we're not trying to necessarily make Asteroids perfect. If you handed a perfect Asteroids game, but then don't know what you're doing, well, then you've kind of shot yourself in the foot. And although the theme is bullets, shooting yourself in the foot is not the theme. So check it out. When I shoot one bullet, and it takes a while for it to charge up again. I get to shoot one bullet every once in a while. I'm just holding down spacebar. So what happens if I change, instead of 100, if I change this to, say, 10? What's the expected change? Just think about that for a second and raise your hand if you got an idea. Instead of greater or equal to 100, what if I change it to 10? What do you think you'll see? More bullets coming at a faster rate. Because it takes less time to charge up to 10. So you can sort of set your rate of fire. I'm going to, just to make this really clear, I'm going to add in a text function just to show us what's going on. I'm going to put it at the bottom of my show function. Don't do this. You don't need to do it. We'll just see it together. So I'm going to print out cooldown at maybe 100, 100. Oh, wait. I'll do it 100, 500. And I'll make the text size pretty big so we can see it. I'm not sure what the fill is at this point. So there's my cooldown. It keeps going up all the time. As long as it's greater than 100, I can shoot. And watch what happens when I shoot. It goes to 0 and starts counting up again. And it takes a certain amount of time to load up back again to 100. And then I can shoot. I think it's actually set to, oh yeah, set to 100. So as soon as it gets up to 100, it's like, it's ready to go. You might wonder, well, why do you keep counting after 100? Couldn't you just leave it at 100? Yeah, you could, but that would be extra code for me to write. I'm lazy, so I'm like, well, you could make it stop at 100, but 700 is also greater than 100, so there's nothing wrong with it. So, I'm happy to leave it. So there it is. So notice that it can't shoot unless countdown, which is represented here, is at least 100. And I just keep on counting up. And if you change that threshold, that 100, which is represented here, then you can change the rate of fire. So I can make it 50, for example. And I'll leave it for you to decide what is the authentic countdown for your Asteroids game. Okay, looks good. Now, immortal bullets. We probably want to make the bullets wrap as well. That's a traditional thing in the game. But I'll leave you guys to do the wrapping of the bullet. I guess just to make sure that our bullets die, the last thing is to have them figure out how to return false. So what's a good way to do that? It's totally up to you, actually. I would just do a counter, just like cooldown. Just count every frame it's alive and decide how many frames will it be alive for. So if you have an int called, I don't know, lifespan or something like that, just increase it. And if every frame, and if it ever gets to a certain threshold, you can decide if lifespan should be 100 or 200 or 500 or whatever. Then at that point, you would return true. Oh, sorry, that point you return false. Whatever gets beyond the threshold. And I'll actually leave you guys to program that. I think I've taken a little bit too much spotlight away from you guys adding in things. So I'll leave that as an activity for you guys to try out. It's very similar to the cooldown. So go ahead and give that a try to get the bullets to do two things. Get them to wrap around the screen just like your spaceship does. And also get them to the alive function to return false if a counter, whatever variable you want, exceeds some arbitrary number, whatever you want to choose for its lifespan. Probably don't make it too small or you won't get to shoot many asteroids. You'll have a torch instead of a gun if you just have it like as a small number. Okay, so I'll leave that for you guys to try out, and I'll stop the video